Hello again. As you know, I'm Eli the Computer Guy over here for EverymanIT.com, and today's class is on VPN, or Virtual Private Networking. VPN allows computers or entire networks to connect to each other over the internet securely. So if you have an office in Seattle and it needs to connect to an office in Washington, D.C. securely, you would use a VPN. VPN is a client-server architecture, so you have VPN servers and VPN clients, and the software allows the VPN clients to securely connect to the VPN servers. Today's class is going to talk about that. We're going to talk about the clients, we're going to talk about the servers, we're going to talk about the theory, how all of this works, and then practical applications in the real world. VPN technology is nowhere near as complicated as most people think. There's a lot of theory behind how VPN works that is very complicated, very sophisticated, very hard to understand. But for you to actually use VPN technology, you basically just click connect, username, password, done. That's about as complicated as it is normally for the average user. The stuff behind it is much more complicated. So this class is going to be on VPN, Virtual Private Networking. Virtual Private Networking allows computers or networks to connect to each other securely over the internet. So in order to understand VPN, or Virtual Private Networking, we have to go back and we have to talk about how the internet was created and what it was created for in the first place. Now, as we've discussed before in the other networking classes, the internet was created by the U.S. military so that the Army could try to maintain communications during a time of massive nuclear attack. So, when you go to the movies and you see these movies about Armageddon or, a nuclear bomb going off in New York. Well, what the Army, what the military was worried about is what happens not if one nuclear weapon goes off, what happens if 20, 30, 40, 100 nuclear weapons go off? What happens if the 50 major cities in the United States suddenly get vaporized? They just no longer exist. How would military units communicate with each other? The reason that they're worried about this is because in the old style of communications, basically with old telephone systems, all communications went through central hubs. So if you were in Seattle and you were trying to contact somebody in D.C., your telephone communication would go through things called central offices in order to get to D.C. Now, on a normal, bright, shiny day, this system works fine. The problem is if one of these central offices is taken out by a nuclear warhead, there is no way to easily reroute this communication to get to D.C. So the Soviets could bomb us, and if they could destroy a few of these central offices, our communications infrastructure would fall apart. Basically, military units on the West Coast could not talk to the military units on the East Coast, etc. That's a bad thing. So what the military wanted is they wanted a way to communicate that would be self-healing, so that very easily, very quickly, if a central hub was destroyed, communications would remain online. That is where they came up with the idea of the internet. So with the internet, all communications are routed through things called routers. So if you're in the US now, there are tens of thousands, maybe hundreds of thousands, who knows, maybe millions of these routers that are sitting on the internet. So if you're in Seattle and you're using the internet to communicate to somebody in DC, you go through any number of these routers to get to DC. Basically, you go to the first router passes you to the second, passes you to the third, passes you to the fourth, fifth, sixth, all the way to DC. Now, why this is important is because if a nuclear bomb goes off here and destroys this router, this system automatically will rebuild a new communications path. So if this router is destroyed, your communication can now get rerouted through other routers to get to DC. If a huge chunk, let's say if 10,000 of these routers are destroyed, you can still communicate with DC. 100,000 routers are destroyed, and as long as they're not the right ones, this will all heal itself and you'll be able to still communicate with whoever it is you're trying to communicate with. Well, the problem with this from a computer security standpoint is you have all of these routers, and these routers actually have the data traffic going through them. So not only is this router here, not only is this router moving traffic from it to the next router down the line, but all of the data is actually going through it. The emails are going through it, files that are being transferred are going through it, etc. So if you're a hacker and you can somehow get into this router, you can collect all of the information that is going through and put it back together and see what people are doing. So if pictures are going through this router, you can grab those pictures and look at those pictures. If confidential information is going through this router, you can grab that information and look at it. This is called a man-in-the-middle attack. So if you're learning about hacking, basically a man-in-the-middle attack is when two people are trying to communicate. You get into the middle of that communication stream and you just start reading everything that is going by. So when the internet was created, from a physical security standpoint, it was very, very good, because if nuclear bombs went off and half these routers are destroyed, communication still exists. From a computer security, from a data security standpoint, it was very, very insecure, because if you could get into these routers or these servers, you could look at all of the information that was going through. You could grab all that information. So that's why they came up with virtual private networking. Virtual private networking allows you to connect over the internet securely. So how it does this is through a couple of security tools. The first is it uses something called a tunneling protocol. So what the tunneling protocol does is when you're trying to connect to this computer server in DC, the tunneling protocol sets up a tunnel between you and DC through all the routers that you're going through. So there's a communication. Then inside this tunnel, it then encrypts all of the information. So you create a tunnel around the information that you're sending, and then you encrypt all of the information in the tunnel to the people you're sending to. And the reason why this is important is because if a hacker is sitting at a router and they're able to see all the traffic that is going through, the first security that they're going to run into is this tunnel that is protecting your encrypted data. Well, if they're sophisticated hackers, they can then penetrate that tunnel. But even if they penetrate the tunnel in order to try to grab your data that's in that tunnel, well, that data is encrypted. So even when they do grab that data, it still doesn't mean a whole lot to them, because it's encrypted. Now, the third thing that makes VPNs very, very, very secure and very good is, as we talked about before, you've got all these routers, and so if you're trying to go to point A to point B on the internet, you may go through any number of these routers to get to where you're going. Well, the cool part with VPN is part of this tunneling protocol is if there is a hacker here and he tries to penetrate this tunnel will try to detect penetrations. So it's, the tunnel's going along, everything's doing fine. If it detects that somebody is trying to hack into it, the tunnel will shut itself down and will recreate itself through another set of routers. So if the hacker is here, he tries to penetrate your tunnel, that entire tunnel is shut down, and then the tunnel finds a new path through the internet. So even if your hacker is still here, well, he's at this router, you're now going through this router, he's no longer able to try to grab your information. So that's how VPN works, is you've got the tunneling protocol. So the tunneling protocol basically, think about it like a tube. Think about it like a data tube that runs all the way through the internet. So that tunnel, that tube, tries to protect your data. Then inside that tube, all of your data is being sent, but it's being sent encrypted. So even if somebody can penetrate the tunnel, all the data that's in there is encrypted. So even if somebody is able to grab the information, it's encrypted. Then beyond that, once they penetrate the tunnel, like I say, the entire tunnel will drop and try to recreate itself. This is how VPN, virtual private networking, works. And as we talked about, why we need it is because the original internet really wasn't secure from a data security standpoint. Now, the final thing that we're going to talk about with this explanation is that you have to remember that VPN, virtual private networking, is a client-server technology. So we've talked a lot about that before in other classes, especially, like I say, the server track. So client-server technologies, what that means is you have one server that provides a service, and then you have a client that tries to connect to the server to get the service. So whenever you're dealing with a VPN technology, you will always have a VPN server. This VPN server will be sitting in your office or wherever it is that you're going to be trying to connect to. Then you have a VPN client. The VPN client is generally installed on the computer that you're using that will be connecting to this office somewhere. So if you're using a laptop computer, you may install or you may use a VPN client that is already installed onto that computer. So what happens is you turn on the VPN client on your computer, on your laptop. It'll say, where are we trying to connect to? So generally you'll give it something like an IP address or an external IP address of where you're trying to connect to. So you know this office here has an IP address of 10.1.10.1, let's say. So in the VPN client, you will put that IP address. You will then put your username and your password. What will happen is when you can try to connect to the VPN server in the office, your connection will go all the way through the internet, zigzag around the internet, and then come here to this VPN server. The VPN server will then look at the credentials that you gave it, the username and password, and then it'll say, is this person allowed on the network or not? If you have the right credentials, it will allow you to be on the network. If you don't have the right credentials, it will shut you out and you won't be able to use the network. So this is the basic system of how VPN communications happen. Now, something that you should understand is that there's a lot of different VPN software and hardware out there. So Microsoft has VPN software. Cisco has VPN software. There's OpenVPN, all these types of things. One of the main things that you have to remember is that whatever VPN server you're using, you have to use the VPN client that will work with it. So Cisco VPN will not necessarily work with Microsoft VPN. Microsoft VPN won't necessarily work with OpenVPN, etc. So this is a client server technology. So we went over the basics of what VPN, virtual private networking, is. So this is where we create a tunnel through the internet so you can securely connect to your office. The tunnel protects your data. The data that is being sent through the tunnel is encrypted, and if somebody penetrates that tunnel, the entire tunnel shuts down and then tries to recreate itself in order to thwart hackers, trying to get into it. Now, when you're doing VPN, this is a client-server technology, so you're going to have a VPN server in your office, the building that you're trying to connect to, and then your laptop computer or your smartphone or whatever will have a VPN client which will then connect to this VPN server. You'll connect using the external IP address. You'll give it your username, your password. That will all be sent to the VPN server. If it is correct, then you'll be allowed to be on the network. If it is incorrect, obviously you won't be allowed to be on the network. But that is the essence of what VPN, virtual private networking, is. So VPN, virtual private networking, allows you to connect securely to your office or organization over the network from wherever you are in the world. So, if you're in Dubai and you're connecting to your office in DC, you can use this VPN tunnel to connect to your office in DC, and your computer, so if you've got a little laptop right here, as far as your computer is concerned, you are actually connected inside this office. So if you hit the print button here in Dubai, you can send a print job to the printer that's sitting here in Washington, D.C. If you need to get to a shared file that's sitting on a computer here in the office in Washington, D.C., you can get to it. You don't have to open any extra ports. You don't have to do anything else fancy with your firewalls or port forwarding or any of that. If you have this VPN connection, As soon as you set this up, your computer thinks that it's inside the building, and the computers inside the building think that it's inside the building. So basically, it allows you to act as if you're local, even if you're, off on the internet somewhere. So there's a couple of things to think about with this that are very, very important if you're going to be using VPN in the real world. Now, the first thing that causes people a lot of problems if you're going to be using VPN is, remember, this computer here is now going to think that it's inside the office, and the computers inside the office are going to think that it's inside the office. Well, remember, you are not on the local area network. You are not on the LAN that has a speed of 100 megabits per second or a gigabit per second speed. Your speed on your computer out here when you go through the internet is whatever the speed of the internet connection is, or actually the speed of the slowest connection of the internet connection. So if you're here, and let's say you have a fiber optic connection, because you're in Dubai, and Dubai people are cool, but your DC office only has a DSL connection, well, remember, DSL, the upload speed is normally 756 kilobits per second, right? So if you are trying to, let's say, edit a 100 meg file, a very large file, that file has to get pushed out over a 756 kilobit per second connection to you in Dubai. That is going to bring everything and make it very, 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 very slow. So the first thing that you have to remember, if you're going to be using VPN in your office organization or your client's organization, is the upload speed that organization has will dramatically affect the users of the VPN. Now, most people don't think about this. If you go out and you get Comcast internet or Verizon internet or any of those internets, they always talk about the download speed. They always talk about 10 megabits per second download, 100 megabits per second download, 3 megabits per second download. They're always talking about download. Very rarely do they talk about the upload speed. Well, remember, with this VPN connection, upload speed is going to be as important as download speed. If you only have a 756 kilobit per second upload connection, VPN is going to be pretty piss poor. It might be good for people trying to check a couple of emails, maybe send out a print job or something. But if they're going to be pushing and pulling a lot of data back and forth, this is going to be absolute garbage. I have a client that way right now. They have 10 users all trying to use VPN. They called me in. They said, Eli, what can we do? Can we buy a new server? Can we buy all this new networking equipment? And I looked at it and I said, no, you need to go to Comcast. You need to pay $200 a month for their, I think it's 100 meg down, 50 meg up connection. If you do that, everything will be A-okay for you. Why? Because they have 10 users all trying to pull data out of the servers in their building, but they have a sucky little 756 kilobit per second connection. So that's very, very, very bad. Now, the next thing that you have to remember with this VPN technology, and this is a problem that I see in the real world, so this isn't just a theoretical problem, is here in Baltimore, we have a lot of old buildings. And a lot of our old buildings have a lot of really old wiring. Really old wiring is bad for transmitting data, so, for DSL connections or cable connections, etc. Well, the problem with this is when somebody's out here, in Baltimore, and they're trying to connect to an office in DC, and they're going through all those routers. Remember, one of the things that the virtual private networking technology does is it says if a hacker is trying to penetrate the tunnel, it will drop the tunnel and try to recreate it using a new path. Well, the question always is what does a hack attack look like? The VPN, the people that program this VPN technology, I have to say what a hacking attack looks like. And a hacking attack generally looks like is if the data signal isn't steady, if the data stream gets slowed down for some reason, if there's too many dropped packets. Well, with really bad, really old wiring drops a lot of packets. Really old wiring slows things down and makes a mess of things. So a lot of times, like in Baltimore, I've seen VPN connections be really bad and almost completely unusable. The reason is because the old wiring in the building is so bad that there's a lot of packet loss. VPN technology thinks that packet loss is hackers trying to penetrate the tunnel. Therefore, the VPN keeps dropping the connection and then recreating the connection. Well, since it's not a hacker, it's the wiring, basically what happens is that the VPN simply keeps dropping and recreating the connection all the time. It's just blah, 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 blah. And so nothing ever gets around to happening. So this is something to realize in the real world, is that if you have really bad wiring in your building, your VPN connection may keep bouncing up and down because the VPN thinks that somebody is trying to hack, trying to penetrate that connection. So these are things to think about in the real world. Again, like I say, upload speed is a very important thing. Most people don't think about it. If you have a 756 kilobit per second connection, you don't want to be using VPN. You need fiber optic, you need, cable, internet. T1, maybe. I mean, T1's not good. That's another thing with VPNs. Realize T1s are old school. T1s are like 15 years old. T1 on VPN, still, I mean, it's okay. I mean, it's adequate, I suppose, but still not very good. The only final thing I will say is you should not run into this. You should not run into this, but I am an old timer, and sometimes you see some really old equipment in the field. VPN at one time, virtual private networking, at one time was a new technology. It was new. A long time ago, like 12 years ago, it was new. But routers that were created before VPN technology was new, or before VPN technology was used by a lot of people, did not allow for something called VPN pass-through. So VPN pass-through allows for virtual private networking tunnels to pass through the router. Like I say, every router built for the past 10 years has this built into it. An 11-year-old router may not have it built into it. So if you're sitting there and you have really old networking equipment and you can't figure out why, VPN isn't working for some reason, it may be that the router does not allow VPN pass-through. If that's the case, then basically you just throw it out and buy a new one. And frankly, if you're dealing with an 11-year-old router, you just need to throw it out and buy a new one anyway. So that's VPN in the real world. So that's all there is to virtual private networking. So virtual private networking allows you to connect to an office or organization's internal LAN, their internal infrastructure, through the internet. So you're sitting out in Dubai, you're trying to connect to an office in DC, you can go through the internet, VPN creates a tunnel, it encrypts the data within the tunnel, and then if any hackers try to penetrate the tunnel, it drops the connection and tries to recreate it somewhere else. And that's really all there is to it. One of the very important things to remember, especially if you're coming from the Microsoft world, is to make sure you understand how simple VPN technology is. Now, if you're coming from the Microsoft world, Microsoft packages a lot of things on top of any of their products. So, with VPN, they have Active Directory and group policies and share permissions and all kind of stuff. What you have to remember is that pure VPN, all VPN does is it creates this tunnel with the encryption and connects you to the internal network. It does not have anything to do with Active Directory. It has nothing to do with group policies, etc., etc., etc. You can put servers on the internal network that allow Active Directory and group policies and all that, but VPN itself doesn't have anything to do with those. So you can set up a VPN connection without needing to know anything about, like I say, Active Directory, group policies, or intrusion detection or any of that. Now, the other thing to remember with VPN is that there are a lot of VPN solutions out there. Probably any VPN solution you're going to come across will work fine for you. The thing is that you have to stick with that VPN solution. So Microsoft, one of the reasons why almost everybody uses Microsoft VPN is because it's built into their servers and their client operating systems. If you buy a Windows server, it has routing and remote access, their VPN server, built into the server for free. You don't have to pay a dime for it. So it's built in the server. Then if you have any version of Windows built after like Windows 95, there's a VPN client built into the operating system. So you just configure the VPN software on the server, you configure the router, and then you set up the VPN client on the computer, and it will be able to connect to the server. It's easy. But remember that if you have a Cisco VPN client, there's a good chance it will not be able to connect to that Microsoft VPN server. A lot of this is very vendor specific. If you use OpenVPN client, you need OpenVPN server. If you use a Cisco VPN server, you need a Cisco VPN client generally. Like I say, Microsoft already has it built in, so, frankly, most of us, we just go with Microsoft. As we talked about in the real world, the two very important things, very, very, very important things that you have to worry about is, remember, your internet upload speed is really gonna matter with a VPN connection. Because remember, since somebody is sitting in Dubai, when they're trying to edit documents, they now have to be able to pull those documents out of your server all the way through the internet over to their computer. So if you're dealing with 100 meg files, 200 meg files, a gig file, that entire file has to get pulled from your server that's sitting in your building, out your puny, pathetic little internet connection over the internet to them. If you have a 756K connection, it's not gonna work very well. Final thing, again, if you're in a city like Baltimore, remember, old wiring is very bad for transmitting data. Data needs good, clean, newish, less than 20-year-old wiring to really be able to move efficiently, effectively. Well, if you have old wiring, a lot of the defects in that old wiring, the VPN software will think that the problems you're having are hackers trying to penetrate the tunnel. Therefore, it'll keep dropping your tunnel because it thinks a hacker's trying to penetrate it, but your wiring stays bad. And so basically, if you have bad wiring, you can have the thing where basically the VPN tunnel just keeps trying to recreate itself, and it all goes bad really, really quick. But so that is what virtual private networking is, VPN. It's a very, 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 nice, relatively easy to use piece of software solution. Again, client server, you have a VPN server. You connect to that server using a VPN client, and like I say, all the tunneling and encryption and all that's done behind the curtain. You really don't have to worry about it. All you have to worry about is what's the external IP address, what's the username, what's the password, and that's it. You just go about your day. So as you know, I'm Eli the Computer Guy over here for everymanit.com. I enjoyed teaching this class and look forward to seeing you at the next one.